Hello and welcome. In today's session, we are going to talk about GMAT combinations and permutations. Before we start, we need to cover one important concept, the concept of a factorial. Factorial essentially is the product of all the positive integers from 1 up to the number whose factorial you want to find. Factorial is normally denoted by an n followed by an exclamation mark or a large L where n is embedded. This is just the mathematical notation for representing a factorial. So factorial of a number n simply is n into n minus 1 into n minus 2 and so on till you reach 1. Quickly, some properties of factorials. Factorial of a 0 you might think is 0 or undefined. However, factorial of 0 is equal to 1. That's just how factorials are defined, and we need to keep this in mind to avoid any silly mistakes. Secondly, factorial of only the natural numbers are defined, which means that if n is less than 0, it does not have a factorial. So that's quickly a summation of what factorials are all about. So let's quickly test our knowledge. Let us find the value of factorial 10 divided by factorial 4 and factorial 6. So I can write it down like this: factorial 10 divided by 4 factorial and 6 factorial. Now this essentially is equal to 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 factorial divided by 4 into 3 into 2 into 1 multiplied by 6 factorial. So this 4 into 3 into 2 into 1 is something I'm getting from 4 factorial. So 4 factorial is 4 into 3 into 2 into 1, and I'm leaving 6 factorial as it is, so I just put that here in the denominator. And so 6 factorial goes out with the 6 factorial, and here 4 and 2 make 8, so 8 goes, and 3, so this becomes 3. So you have the answer as 10 into 3 into 7, which essentially is equal to 210. Clear? Good. Okay, let's see if you really understood the concept of factorials and how to use it in a GMAT kind of problem. So this is a typical GMAT question. If it is required to seat 3 men and 2 women, so 3 men and 2 women in a row such that the women occupy the even places, in how many ways can this be done? To do this question, let's look at the number of places we have. So we have 1, 2, 3, 4 and 5 places in all, and we need to seat 3 men and 2 women, and women to occupy even places. So this is even and this is even, so let me say women 1 here and women 2 here. So 2 women go here on number 2 and number 4, and the men occupy the remaining places 1, 3 and 5. So how many ways can 3 men fill 3 spaces? That is given by 3 factorial. It simply means that the first man can occupy either 1 or 3 or 5, which is 3 ways. After he's occupied one of the 3 seats, there, say he occupies seat number 5, so seat number 5 is gone, and now there are 2 men remaining and 2 places, 1 and 3. So the second man can occupy either seat 1 or seat 3, which means he can do it in 2 ways, and the third man has only 1 seat, which means he can only do it in 1 way. So the total number of ways in which 3 men can occupy 3 seats is factorial 3, and which is 3 into 2 into 1, which is equal to 6. And in how many ways can 2 women occupy 2 places? So the first woman 1 can go either to number 2 or number 4, so that is 2 ways, so which is 2 ways, and the second woman then has to take the remaining seat, which is only 1 way. So this is 2 into 1, which is equal to 2 itself. So now we know that the men can occupy their seats in 6 ways, and the women can do it in 2 ways, and so the answer you're looking for is 6 into 2, which is 12 ways. So here is the formal official explanation. In a row of 5 positions, there are 2 places that exactly 2 women can occupy, and that's possible in 2 factorial ways. The remaining 3 places can be filled up by 3 men in factorial 3 ways. Hence the total number of seating arrangements is 2 factorial into 3 factorial, which is 6 into 2, 12. What is important here is to understand why 3 men can occupy 3 chairs in factorial 3 ways. So going back to our earlier explanation, if you have 3 chairs, chair number 1, chair number 3 and chair number 5, remember the even chairs are occupied by women, and you have man 1, man 2 and man 3. The way to look at it is this: man 1 can go to either seat number 1 or seat number 3 or seat number 5. So there are 3 ways in which you could potentially do it. Now after man 1 has taken one of these 3, man 2 will have only 2 of them left. So assuming man 1 goes to seat number 5, in that case man number 2 has seat 1 and seat 3 left to occupy, which he can do in 2 ways. Now let's assume that man number 2 has actually gone to seat 3, which would mean that man number 3 has only 1 seat to go to, which means he can do that in 1 way. So you're looking at multiplying 3 by 2 by 1, which basically is equal to 3 factorial. So 3 men can occupy 3 seats in factorial 3 ways. A very important concept, and probably the backbone of trying to understand permutations and combinations. Okay, coming over to permutations, let us look at the formal definition of permutations. Permutations can be defined as the number of ways in which R things at a time can be selected and arranged at a time from amongst n things. So the keyword here is selected and arranged. So you're not only talking about taking out things, but also how you're going to arrange them within themselves. The keyword again is arranged. Hence permutation is basically referred to as ordered selection. When we cover combinations, we'll see that combination is merely selection, whereas permutation is ordered selection. The formal symbol of a permutation is NPR, which basically means that this is the number of permutations, arrangements of n things taken R at a time. And this is what the formula equals. The permutations of n things taken R at a time is equal to factorial n divided by factorial n minus R. So this is the first application of the concept of factorial that we learned a while back. So some typical situations where permutations are used are things like making words and numbers from a set of available letters and digits, filling posts with people. So if you have 5 posts of vice principal and 10 people to take them, how many ways can the post be filled? These situations refer to the GMAT kind of problems that would be set around permutations. So let's take a quick example to see how the formula for permutation is used. What's the permutation of 6 things taken 4 at a time? So simply using our formula, we have 6 things means 6 factorial divided by 6 minus 4 factorial, which basically is, as you see in this equation, comes to 360. The important thing is not just knowing the formula, but being able to apply it logically. It's very easy to get confused with permutations, combinations, probability and factorial. So what I found most effective with people who score high on the GMAT is you take down the problem to its basic parts, use logic. For example, when we were trying to place 3 men on 3 seats, how did we do it? Very logically, and then we saw that the answer is the same as 3 factorial. Similarly, use logic, use counting methods and try to get to the solution, and then if you're sure that that's the way to go, then use the formulas like these to double check that you are on the right track. A couple of important permutation rules to keep in mind. So the first one is number of permutations of n different things taken R at a time when repetition, keyword repetition please note, is allowed is n to the power of R. This is because the first place can be filled by any of the n objects, and since repetition is allowed, the second place can be filled by the same n ways again. Thus there are n into n and so on, n to the power of R ways of filling the first R positions when repetition is allowed. Let's see if this is clear. Let's try to do this simple question. In how many ways can 5 marbles be chosen out of 100 different marbles if each time the marble that is taken out is replaced? Now replaced gives us a hint that we are talking about repetition here. So let's break this problem down into the basics. You've got 100 marbles. How many ways can you take out one marble from 100? There are 100 different marbles, yeah? All marbles are different. So the first marble can be taken out in 100 ways. Now, you put the first marble back because it is replaced. And then when you take out the second marble, you've again got 100 marbles. So how many ways can the second marble be taken out? Again 100. And the third marble, again 100, because each time you're taking out a marble, you're replacing it. So this goes on 5 times. So the answer would be 100 multiplied by itself 5 times. So 100 to the power of 5. Okay, the second key principle of permutations: number of selections of R things out of n identical things is equal to 1. So notice the keyword is identical. In the previous example, the 100 marbles, all marbles were different. In this case, they are identical. So let's look at a quick question again. In how many ways 5 marbles can be chosen out of 100 identical marbles? All marbles are the same. So what do you reckon is the answer? The answer is 1, because all the marbles are the same. So if 5 people, suppose, had 5 jars of 100 marbles each, now the first one takes out 5 marbles, could be any 5. The second one takes out 5 marbles, the third one and fourth one and the fifth one, and so on. Now because all the marbles are identical, so the 5 marbles for each of those 5 persons is going to be exactly the same. There's only one way that you can take out 5 marbles from 100 identical marbles. So that is the key concept here, and it's important to understand that. Moving on to combinations. A quick definition and a few examples first before we start working on the more difficult problems. So combination is defined as the number of ways in which R things at a time can be selected from amongst n things available for selection. Now please note the difference. Here it's only selected, not arranged. So the way those things might be arranged does not make any difference in the number of combinations, because we are only doing the first step here. We are only doing the selection and not the subsequent step, which could be an arrangement. So the symbol for combinations is NCR. Just to refresh memory, the symbol for permutation was NPR. So the keyword here is selected, and the order in which they are selected has no importance. So the formula, which may not be very clear here, so let me just write it down quickly, is NCR if R things are selected from n objects, then the number of ways in which that can be done is n factorial divided by n minus r factorial multiplied by r factorial. This is the formula for calculating combinations. And of course this formula assumes that the number of things being selected is not greater than the number of things available to select, which is quite an obvious thing really. But when covering formal definitions, we have to cover scenarios where not so obvious things can happen, especially while solving a mathematical sums. So some of the situations where combinations may be used are things like selection, people for a team, for a party, selection of objects from a larger set, and so on and so forth. So once again, just to highlight the difference between permutation and combination, is that in permutation the ordering of objects is important, while in a combination it is immaterial. So for example, if you have two letters A and B, A and B can be selected as AB or BA, and these are two different permutations but the same combination. And normally the number of permutations always exceeds the number of combinations. So we're not talking about trivial cases here at the moment where you're not selecting anything. So R is 0, for example. So AB and BA are different permutations but same combination. That is the critical difference. Now you do not really need to remember whether a question is asking you to find a permutation or a combination or a factorial. You just deal with the question logically, and then at the end of it, when you know what you have to find, you can use the appropriate formula. Okay, now that we've covered the basic definitions and some simple rules, let us look at a typical GMAT kind of problem around combinations and permutations. So if there are 10 people in a party, and if every pair of them shake hands with each other, how many handshakes happen in the party? So that's the question. This is a typical kind of concept that is tested on the GMAT on a fairly regular basis. So what you need to do is thinking about this logically. So you have 10 people. Let's just write them down. So 1, 2, 3, 4, 5 and so on, and 9 and 10. Now the first person is going to shake his hand with 9 people, so this with 1, 2, 3, 4 and so on. Yeah, so except himself, he's going to shake his hand with 9 people. So the first person here shakes his hands with 9 people. Now the second person, he's already shaken his hand with the first person here, so he's got 8 remaining people to shake his hands with. 8. Third person similarly has 7. The fourth person 6, and the ninth person has only Mr. 10 to shake his hands with, so 1, and 10 person has no one because the others have already all shaken his hand. So you see here that we are going from 9, 8, 7, 6 all the way to 1. So essentially the total number of handshakes would simply be 9 plus 8 plus 7 plus 6 all the way to 1, which basically totals 45. So if you add 1 to 9, you'll get the answer 45. You can also use the formula for doing this, which is basically the sum of first n natural numbers is n into n plus 1 divided by 2. So here n is 9, so this becomes 9 multiplied by 10 divided by 2, which is 45 again. So this formula is basically something not in scope for probability and permutation combinations, but this is covered in another video session that we will do later on. So now you've broken the problem down into its basic parts and found out by the core logic, using core logic of how many handshakes actually happen, and arrived at an answer of 45. But you need to also cross-check whether were you to use your newfound knowledge of permutations and combinations, how does it work? So let's clear all this and see. So essentially what the problem is saying, if you want it into the context of combinations, is that we have to consider 2 people, how can they be selected from 10 people? So that can be done in 10C2 ways. So you are selecting 2 people because it's 2 people who are shaking the hand, and you need to find out how many handshakes happen, which will be the same as the number of ways in which 2 people can be selected out of 10, and that is 10C2, and that is equal to 10 factorial divided by 2 factorial into 8 factorial, which basically is the same answer you got earlier, 45. So from a GMAT perspective, it's good to know how to solve it using a quick permutations and combinations formula. At the same time, sometimes these questions get very confusing, so you should have a backup of how to solve it using the very basic logic. Okay, let us look at the next example. So here we have 7 letters M, N, N, O, P, Q, R, S, and we need to find the number of ways in which these 7 letters can be arranged so that P and Q occupy continuous positions. In problems of permutations, combinations, and probability, you need to be careful about the words used in the question. So here continuous is a keyword here. So how do we approach this problem? Let's start by taking P and Q as one letter and try to find the number of ways. So if P and Q is one letter, then we've essentially got 1, letter 1, 2, 3, 4, 5 and 6 letters. So we need to arrange 6 letters. Forget about whether it's combinations, permutations, what. Let's break it down into the basic chunks. So we've got to arrange 6 letters in 6 positions. So let's say this is position 1, 2, 3, 4, 5 and 6, and I've got my letters M, N, O, P, Q, which is one letter, R and S. So how many ways can letter M go somewhere? So it could go either to 1 or to 2 or to 3 or to 4 or to 5 or to 6. So 6 ways. Yep. So let's assume it goes to 1. So let us take out everything else. Now, in how many ways can N go to a place? So N can go to, let me just use a different color for N. So N can go to 2, 3, 4, 5 or 6. So this can go to 5 places. Now assume N has gone to 2. It could be anything, doesn't have to be 2. N could go to 3 or 4 or 5 or 6, so 4 places. And PQ combination similarly could go to 3 places. R could go to 2 places, and S would have only 1 place to go. So the total number of ways in which the 6 letters M and O PQ combination R and S can be arranged in these 6 places is 6 into 5 into 4 into 3 into 2 into 1, which essentially is equal to 6 factorial. Now, is the answer 6 factorial? This is where we need to go back to the question and read it again. So it says, in how many ways can 7 letters be arranged so that P and Q occupy continuous positions? So the question is saying P and Q need to occupy continuous position. So this calculation that we've just done, we've assumed PQ to be one combination, but how about if we turn it around and make it QP? Does it still satisfy the conditions in the question? It does. So essentially the answer isn't complete. We need to now consider QP, and hence we have 2 internal positions that Q and P can occupy. So we need to multiply 6 factorial by 2, and that is the answer. And here is the formal solution. Essentially what it's saying is that for arranging 7 letters P and Q together, we create a new dummy letter called PQ, and then we arrange the balance in a linear arrangement, and that is like arranging 6 letters in 6 places, which is nothing but 6 factorial. However, the solution is not complete because P and Q can be Q and P, and then that can be done in 2 factorial ways, and the final answer being 6 factorial into 2 or 2 factorial, which is the same thing. Okay, let's look at another example. You need to split 8 players into 2 distinct teams of 4 each. So this is a simple case of combination. So applying the formulae that we learnt, this is equal to 8C4, which is basically 8 factorial divided by 4 factorial into 8 minus 4, which is 4 factorial, and this comes out to be 70. So this question essentially is application of a simple combination formula. In how many ways can you select 4 players out of 8 players to form 2 teams? So once you've selected these 4 players, the balance 4 would automatically go to the other team, and that's how you break down the problem into its logical steps and then apply this combination formula. So to do this problem, essentially what we're saying is simply find out how many ways can you select 4 players out of 8 players. The 4 selected would go to team 1, and the remaining would go to team 2. So given that team 1 and team 2 are different, the number of ways would be given by simple combination, 8C4. Now looking at the second step of this problem, here they're saying that the teams are non-distinct. So basically T1 is exactly equal to T2. So now if we divide the number of players, say T1 has player 1, 2, 3 and 4, and team 2 has player 5, 6, 7 and 8. This is one combination. out of the 70 that we got. So this is 1, and out of the 70 that we got, if we just reverse this, so this becomes 5, 6, 7, 8 player here, and 1, 2, 3, 4 here. This is another combination from the 70. Now essentially the second part of this question is saying that this combination, let's call this combination 1, combination 2. 1 and 2 are the same because T1 is equal to T2. Teams are non-distinct. So what we need to do now is, because the teams are non-distinct, we need to essentially divide 70 by 2. And for the second one, the answer is 35. For the first one, the answer was 7070. Now let's look at a more formal way of solving this. So essentially what it's saying is 8 players, 4 can be selected in 8 C470 ways. The remaining 4 players form the other group. But if we check, there are 2 factorial groups. So in this case there are 2 groups basically which give the same division. So if 1 2 3 4 goes to one and 5 6 7 8 goes to the other one, then this pretty much is the same thing as if you reverse the 2 players. So in this case the answer would be 70 divided by 2, which is the same as 2 factorial in our case, which is 35. So let us look at the next example, which is how many different committees, each composed of 2 dentists and 3 general physicians, can be formed from a group of 4 dentists and 5 general physicians. So essentially what is the question asking? The question is saying that you've got 4 dentists. How many ways can you select? 2. So that would be 4C2. And then it's saying you've got 5 general physicians. How many ways can you select? 3. 5C3. So this is the way you can select 4 dentists, 2 dentists out of 4, and this is the way you can select 3 physicians out of 5. And you need to form different committees which have 2 dentists and 3 general physicians. So the answer would be the number of ways you can select 2 dentists out of 4 multiplied by the number of ways you can select 3 physicians out of 5. So let's calculate this. 4C2 is basically So 4C2 is 4 factorial divided by 2 factorial divided by 2 factorial, which is 6, and 5C3 is 5 factorial divided by 3 factorial into 2 factorial, which is equal to 10. So the answer is 6 into 10, which is 60. So this is the answer C, which is 60, and here is the explanation. So 2 dentists can be chosen from a group of 4 in 4C2 ways, which is 6 ways, and 3 general physicians can be chosen from a group of 5 in 5C3 ways, which is 10 ways. and so the overall answer is 60. So hope you enjoyed this session. Please leave your feedback to help us with the further GMAT Math sessions that we are planning. Thank you very much.